Welcome back to the Deep Dive. Today we're jumping right into what's often called the crisis of confidence in behavioral sciences.
Right. It's this growing concern that a lot of findings are maybe fragile, hard to reproduce consistently.
Exactly, and a big part of that seems to be what they call the garden of forking paths.
Yeah, that's a great term for it. It's basically all the, seemingly small decisions a researcher makes. How do you handle outliers? What about missing data?
Each choice might seem reasonable on its own, but pile them up?
And you can end up with wildly different conclusions from the exact same raw data. That's the core issue, really. It shakes confidence.
So our mission today is to unpack a potential solution, the multiverse analysis, and specifically a new crowdsourced version.
Which aims to make the whole process more objective, less about the individual researcher's choices.
And we'll use a specific case study looking at semantic priming, basically how quickly we link related words like doctor and nurse across English and German. Does that effect hold up robustly?
Okay, so a traditional multiverse analysis, how does that work? The idea is instead of just picking one way to analyze your data.
Like one path through that garden.
Exactly. You try to map out all the plausible paths. So maybe you have, say, 2 ways to deal with missing data.
Okay.
And maybe 3 ways to define an outlier.
Right.
And 4 different rules for excluding certain data points.
You see, multiply those 2 times 3 times 4.
Yep. That gives you 24 unique analysis pipelines. You run all of them.
That definitely sounds more thorough than just one analysis. But wait, couldn't a researcher still cherry pick?
That's the key limitation, yeah. If you run 24 analyses, what stops someone from only reporting the pathway that gives the most, let's say, exciting result?
Or maybe they only include pathways they suspect will give them the result they want?
Precisely. It still leaves those researcher degrees of freedom wide open. The bias can still creep in when defining which paths are plausible.
Okay, so that brings us to the crowdsourced approach. How does that try to lock things down?
It's pretty clever, actually. It's a structured 4-step process that relies heavily on, well, the crowd, expert input.
How does that work? Elicitation and validation.
Yeah. First, step 1 is elicitation. They survey dozens, sometimes hundreds, of experts in the specific field, and they dig through the literature.
To find every possible way people handle these data processing decisions.
Pretty much. Every defensible method for dealing with outliers, missing data, you name it. Then comes step 2, validation.
So getting experts to agree on which of those elicited methods are actually like standard or appropriate for this specific research question.
Exactly. It weeds out the noise and builds a consensus before you even touch the main data set. It creates a community-endorsed set of rules.
That sounds like it seriously limits an individual researcher's ability to steer the results.
It aims to take it out of their hands entirely, make it transparent and pre-registered.
And the scale they reached in this priming study is just wild. They initially synthesized pathways that theoretically added up to over 1.7 billion.
A billion, yeah. It sounds computationally impossible, but that's the conceptual space before the validation step narrows it down to the most relevant and agreed-upon set.
Okay, so let's get to the case study results then. The big question was, do these item-level semantic priming affects the strength of connection for specific word pairs correlate across English and German speakers?
Right. And is that correlation robust, or does it bounce around depending on how you process the data? They had a big data set, too, over 8,800 people, 1,000 word pairs.
So what did they find when they compared different approaches?
Well, first they did a sort of many-analyst approach. They took 53 analysis pathways that individual experts said they preferred.
Like, what did that show?
That showed correlations ranging from 0.20 up to 0.33. That's quite a spread. Suggests the result is pretty sensitive to those choices.
Okay, a bit fragile, maybe. So how did the big crowdsourced multiverse compare? The one with 11,520 validated pathways.
That's where it gets interesting. The range there was much, much tighter.
How tight?
It only went from 0.27 to 0.31.
Wow. So still a positive correlation, but much more consistent across thousands of different valid analyses.
Exactly. The key takeaway wasn't just finding the effect, but showing it was robust. Consistently positive, and the uncertainty around its size shrunk dramatically when using the crowdsourced method. It suggests the finding isn't just an artifact of one particular way of cleaning the data.
So for you listening, the idea here is that this crowdsourced multiverse approach tries to replace those individual, sometimes arbitrary researcher choices with a transparent, community-vetted process.
It's about building a more dependable path to scientific knowledge, stabilizing our findings.
Definitely feels like a step towards more reliable science. But here's something to think about, a final thought for you.
Yeah, huh?
This study, as massive as it was, really focused on standardizing the data processing choices, the cleaning, the filtering.
Right.
It didn't really tackle different statistical models you could use for the main analysis itself.
True. They mostly used similar core models across the pathways.
So what happens if future crowdsourced multiverses start incorporating wildly different analysis approaches too? Different types of regressions, Bayesian versus frequentist methods, you name it. Would results stay this stable? Or will we see that garden of forking paths bloom in a whole new way?
That's a really good question. Something to watch for sure.